All right. Hello, everyone. This video is for solve for trig equations. We have done different practice so far. So this video is focused only on one scenario. Now, for example, we have done sine x. Now, if that is a number, now of course we do understand this number is smaller and equal to positive 1 and larger and equal to -1. So in this case, and of course, for solving x, now x equals to sine inverse of a. All right. Now, depends on a is a positive number or negative number. We definitely have already touched upon how to find the reference angle, just to treat a always as a positive, and then use our knowledge about the sign of each trig values in a different quadrant to understand how to find the x. Now this video, we specifically deal with when this is not a sine x, then that is a sine either 3x or sine 2x or sine x over 2, means this angle is being cut into half. Now in this case, how can we solve for x? I'm going to use three examples just to show the way that I approach this type of solving. Okay, so now first example I'm going to demonstrate is this. It is all in the textbook, but I'm just showing the procedure that I do. So this is a 2 sine 3 theta plus 1 equals to 0. All right. Now, first of all, we wanted to get to this a, which is 1 theta is within this 2 pi range, or let's say just use the degree, 360 degree. That's one thing. Now, second is extended to the general form, right? Okay, so the first thing that I do is that I will say, okay, well, if sine theta, if the theta here it is 360, then that means in 2 theta here, that would be extended to 2 multiplied by 360. Oh, sorry, this is 3. So if it's a 3, then that means this is a 3 multiplied by 360. And over here, of course, 0 multiplied by 3 is still 0. So this is from now, the 3 theta now is from 0 degree now into the triple of the 360. All right, so now the rest, first of all, what I do is just same as we do for the other practice, one only just a theta. So now just treat theta as just one angle. So then that means move the, I'm just quickly doing this, all right? So this is this equals to -1. So in this case, now we do know sine this equals to -1 over 2. All right, so -1 over 2. So in this case, because the reference angle will be the positive, so the reference angle will be 3 theta equals to positive 1 over 2. So now 3 theta will be pi over 6, right? Pi over 6. Now, because now this is a negative, so because this is a negative, so then we do understand now the 3 theta 1, this is always I do, differentiate the two angles. So this will be in the third and the fourth quadrant. So that will be the, well, I guess perhaps we just use a degree. Okay, so degree here will be 30 degree. Okay, so then this will be 180 degree plus 30 degree. That is my theta 3, theta 1. So then that turned out to be 210 degree. Now the other one, 3 theta 2, that will be 360 degree, subtract 30 degree. So in this case, then that will be 330 degree. All right, so now you see that I have 3 theta, have this 2. However, now we do understand the 3 theta, now it is in the 3 of this 2 pi range. So this is already with 1 2 pi range. So then in another case, if this is the 1 and the 2, furthermore, we can think there's another 4 solutions because we will be going into the second 360 degree, and we're going to get into the third 360 degree. So in my case, now I will be doing the 3 theta 3, that will be the 210 degree. Now add on to another 360, add on to another 2 pi, and then 3, the theta 4, that will be equals to 330 degree. Now add on to another 360 degree. Well, on top of that, we still have another 2, because if it's in 1 2 pi, we have 2 solutions. Then in 3 2 pi's, we have 6 solutions here. So then our 3 theta 5, that equals to 210 plus the doubled 360. And then 3 theta 5 equals to 330 plus the doubled 360 degree. All right, so now I got all this. This is all 333. So in terms of that, then in terms of how much the theta is within, so how much the theta here, let me go change to another color. So how much the theta here in the 360 degree, then I just divided both sides by 3, divided by both sides by 3. Okay, there's here the same thing by 3, here by 3. Now here it is, you can add this and divide it by 3, and this you can add this divided by 3, or in other words, you can divide it by 3, each one of them, and you add them together. That is going to be exactly the same thing. You can do whatever you want. So then you will get yourself, oh, there's another 3 here, and you will, oh, this should be 6, sorry. So then you would have 6 solutions. All right. So now the 6 solutions within 360 for theta. Now we have theta 1 now equals to 70, because 210 divided by 3. And then we have theta 2 equals to 110. And then we have theta 3 equals to 190. There's a little bit tedious here, just bear with me. I'm just trying to somehow give you a complete solution here. Now then we have 230 and 5. We have 310 and 6. We have 350. Look at this. This is all within 360, from 0 to 360. So we got 6 solutions here. All right. So this is our A. Now, how about our B? So let me change to B. All right. Now B, the way that I write is that I just use the two original solution here. I will not add on a pi, 2 pi, and add on a double 2 pi. The reason why is because if I go by 2 pi, n of 2 pi, these 3, 4, 5, and 6 solutions are all included in there. So what I'm trying to say here is that I would just say 3, the general solutions, the 3 theta 1, that equals to 210 degree plus 360 degree multiplied by n, this double, all right? Not double, the n times of 360 degree. Now in this case, right away, I'm going to divide both sides, So now this is a 3, and this is divided by 3. So it terms general is theta 1 equals to 70 degree plus 120 n, and then my theta 2 equals to 110, because what happens is like what's right here. 3 theta 2 equals to 330 degree plus 360 multiplied by n. So in this case, I'm going to divide it by 3, divided by 3 here. So therefore, my theta 2 is 110 degree plus 120 degree multiplied by n. So this is my general solution. So note, if you get the theta 1, theta 2 here already by divided by 3, well, then you can see in general solution that is 70. Now here, this is 110. General solution, that's still 110 for without 3 theta, only the theta 1 and theta 2. Then this one will change. See, this one will change. Now, because the sign is go by 2 pi, but here, then you have to divide it by 3, becomes now 2 pi divided by 3, or 360 divided by 3. So this one is different, all right? Compared with the 360 degree of how many, the n. All right, so now let's do another example, which is the half. Should I go another new page? Okay, so I go a new page. Okay, go new page. So now next example is that solve for 10. This time is x over 2. Now plus 4. Now this one equals to 0, all right? Now this one equals to 0. So it here says again, for a, we need to solve for x, that x is smaller than 2 pi and larger than 0 pi. And then the second is again going to the general form, okay? All right, so now we're doing the same thing to solve for this, or before that, I always, as I said before, I always want to say, okay, well, x is within this, then now how about the x over 2? So then x over 2 should be smaller than pi and then larger than 0. So I have to keep this in mind. Okay, so then let's start solving. Okay, so this is very quick. So this is a 4 tangent x over 2 equals to -4. Now therefore tangent x over 2 equals to -1. So when this is a -1, so that means we do understand then x over 2 would have two solutions. One is in the third quadrant, the other one is in the first one is in the tangent, so it's in the second and the fourth quadrant, right? So then this one equals to -1 equals to 3 over 4 pi. So this x1 equals to 3 over 4 pi. Now x2 equals to x2 over 2. Then that equals to, because it's a 2 pi minus 1 over 4. So then this is 7 over 4 pi. All right. Okay, so now let's take a look. We have already said that x over 2 has to be smaller or equal to pi. Now this one, obviously, this is larger. There's no equal thing here, sorry. This is larger than pi. So now therefore, we don't even have this solution to be considered anymore. So now we just have this solution here to be considered. So then in this case, now x1 now equals to 2 multiplied by 3 over 4 pi. Now cancel and cancel, so this is 2. So therefore x1 equals to 3 over 2 pi. So in this case then, we have, as I said, the way we write the general solution. So if this is for B, the way we write the general solution is I'm just going to use this. So the x1 divided by 2 now equals 3 over 4 pi plus n pi. Note, because tangent is by pi instead of 2 pi, right? So then n multiplied by pi. So then in this case, the general form will be x1 now equals to 3 over 2 pi plus 2 pi n, or 2n pi, 2n pi. All right? So now again, I want to point it out that if you already did the x1 here, x1 is this one here. So this one and this one, they're equal, they're the same thing. Now only the general form by either by pi or by 2n pi or by better solution writing, this how many pi, these ones are changing. These ones are changing. All right. Okay, I thought about demonstrating another example, which is in the textbook, and that is just do it a 2x, but the video will be too long. So I think that we should be good just with these two examples. Thank you for watching.